Hi guys, today's lesson is on electronic structure, and this looks at the atom in a bit more detail, like how do you arrange the electrons that a particular element has. So before we look into that, let's have a look at today's starter questions. What is the definition of an isotope? Well, an isotope is an element with the same number of protons but a different number of neutrons. Right, the next question. Draw a labelled diagram to show the structure of an atom. We're actually going to put this on hold for a second because I'll draw that on the next slide. The final question says, what is the definition of a mixture? A mixture is where you have at least two different substances but they can be separated by what we call physical techniques. Now, a physical technique is something like filtration. Right, let's get on to today's lesson. And I did say we was going to look at the nuclear model of an atom. Now, just to recap, in an atom, you've got the centre, which is the nucleus. And in the centre of the nucleus, you have two subatomic particles. You have positive protons, and you also have neutral neutrons. But that's not it. You have one more subatomic particle, and that exists around the outside of the nucleus in something you called a shell, or an energy level. And in these you will find negative electrons. Now what we're going to do today is look at where the electrons are and in what order they're sort of arranged in. But before we get into that, you need to know some more rules on how to arrange electrons and how we find them in an atom. The first rule is that electrons are housed in shells. Well, we already know this from our previous videos. The second rule is that the first shell of any element can only hold a maximum of 2 electrons. It doesn't always have to have 2 in, but it can only hold a maximum of 2. The second shell can hold a maximum of 8 electrons, and the third shell can hold a maximum of 8 electrons as well. And we call this the 2-8-8 rule. You only have to remember these 3 energy levels, or these 3 shells. If you did want to know the other shell, the fourth one, it's the 2-8-8-2 rule. But you won't have to ever go past the fourth shell. Now let's have a look at helium and how we would sort of see that if we was to do the electronic structure. Well, before we get into drawing the structure, we have to look at the protons, electrons and neutrons that an atom has. So the protons, well, we know this is the small number here. So protons is 2. The number of electrons is also the same as the number of protons. So if it has 2 protons, it must have 2 electrons. And finally, the number of neutrons. To do that, it's the mass number, the larger number, minus the small number at the bottom here, the atomic number. So it has 2 neutrons. Now what would that look like as an atom, as an electronic structure? Well, let's have a look. Well, we know that helium has 2 electrons. It has 2 protons, and it has 2 neutrons. Now before we go any further, it is so important that you know where you find these subatomic particles in an atom. If you don't know that, or you're a bit shaky, you need to go back and you really need to revise that and perhaps look at another video. Now the ones that go in the nucleus of an atom are the protons and the neutrons. Now you don't really need to include these for an electronic structure, but we'll do it for completion anyway. So you'll have 2 protons and you'll have 2 neutrons. They're in the nucleus. But what do we do with electrons? Well, this is where our rules come in really, really handy. If we draw circles or shells around the nucleus and we follow our rules, we'll know where to put these electrons. If you look back, you'll know that in the first shell we can hold a maximum of 2 electrons. Well, that's good because we have 2 electrons. So they go in the first shell, and we represent these as X's. If you fill the shell and you have no more electrons to place, then you don't have to draw the second shell. Let's have a look at some others. So we've got chlorine here. Now chlorine on the periodic table is here. And you'll see that it has 17 electrons and 17 protons. Now I've blanked out the nucleus. We're not going to bother with that today. We're going to be focusing on where the electrons go. So we have 17 electrons, and we must follow the 2, 8, 8, 2 rule. So what are we going to do with these 17? Well, 2 can go in the first shell. Then we still have enough to fill this shell, which is the 8. So we're going to put 8 in the second shell. And notice how I'm pairing these. You don't have to do this, but I just do this for neatness, and it's a little more accurate. Now, we've done 10 of our 17 electrons here. We only have 7 left. So we can't fill the third shell, but that's okay. It can hold 7. It will just have 1 extra space left in the third shell. So if you add that up, you'll see that we have 17 electrons, which matches the 17 you find on chlorine on the periodic table. Let's have a go at another one. Now the next one is neon. Neon is here. Neon has 10 protons and also 10 electrons. So if we're following the 2882 rule, we can fit 2 in the first shell. That leaves us with 8 electrons left to place. Now the second shell can hold a maximum of 8 electrons, so they all go in there. 1, 2, 3, 4, 5, 6, 7, 8. That's neon's 10 electrons. Hopefully you're getting the hang of this. Now I've got some here for you to have a go at. You will need a periodic table. Remember to look at the atomic number to find out the number of protons, and that's the same number of electrons. Then you must use the 2882 rule to place these electrons in the correct shell with the correct number. So pause the video and have a go, and then unpause for the answers. Now we looked at chlorine and neon on the last slide, so we're not going to do chlorine and neon. But let's have a look at the other 4. Oxygen has 8 electrons, so 2 in the first shell, and that leaves us with 6 left, so they go in the second shell. Potassium, K, that has 19 electrons, 2 in the first shell, 8 in the second shell, which brings us up to 10, and now we have 9 left. Well, that's a problem because this third shell can only hold 8, so we put the 8 in, and that leaves us with 1 extra electron. Well, what you need to do is draw another ring around potassium and add the final electron in there. That's a tricky one, just to see if you're keeping up. Beryllium and lithium are a little easier now. Beryllium has 4 electrons, so 2 in the first shell and 2 in the second shell. Lithium has 3, so 2 in the first shell and 1 in the next. Okay, hopefully you got that one. Sorry if potassium tripped you up. It was there to try and see if you understood. Let's have a go at some other questions. Right, and the final thing we're going to go through today is what's called the electronic structure. And this tells you in what order the electrons are found in. So let's go back to the 2 examples we looked at when we was doing this, our chlorine. So just to reiterate, chlorine has 17 electrons, 2 in the first one, 8 in the next one, and then 7 in the final third shell. Now the electronic structure is a quick way of telling you how many electrons are in each of these shells. And all you have to do is count the number of electrons in each shells and separate them by a comma and put that number into brackets. So for example, the first shell has 2 electrons, comma, 8 electrons, comma, 7 electrons, and close it with some square brackets. So that's the electronic structure, or the electronic configuration, I should say, of chlorine, 287. Let's try neon. Well, neon had 10 electrons, 2 in the first one, 8 in the next one, and its electron configuration would be 2, 8, because it has 2 in the first shell and 8 in the next shell. You'll only ever be expected to go up to 3 shells in your GCSE. The 2882 rule is to push you that little bit further. But if you only want to remember 288 rule, that's absolutely fine. That's all you will need for your GCSEs. Right, I'm going to leave with 4 questions to have a go at now. Like always, if you need any support, leave a comment in the box below and I'll try and get you a worked example. Thanks for watching. Bye.